Last one of these, and it's a titration calculation. There's no Unit 4 stuff on this review because we just did Unit 4. All right. So here we have a titration going on, and we want to know what's the pH after we've added a certain amount of base. All right, so the first thing we need to take a note of is this is perchloric acid. So this is a strong acid. And lithium hydroxide is a strong base. So strong and strong. At neutralization, pH is always 7. So there's no buffer going on here. So that's helpful. So let's write a reaction for what is going to happen. ClO4, LiOH. That is going to make water and lithium ClO4. All right, this is a neutral salt. It has no pH properties. It doesn't matter. Okay, so we still need to deal with a BCA table though, because when we do these titrations, we know that we're dealing with moles of acid and moles of base. So here, if we have 0.18 molar times 100, that gives us 18 millimoles. So here, let me do this. Acid, 0.18 molar times 100 mLs. And our base is going to be 0.27 molar, and we're adding 100 mLs of it. So that's going to be what, 27? Okay. None of these have pH properties, so we don't care about them. One of these is going to go away. Which one is it? Dr. B, it's going to be the smallest one. Yes. So there's none of that left. That gives us 9 millimoles of strong acid. So that would be, or strong base, sorry, OH minus. Okay. So let's figure out our concentration of hydroxide. This is a strong base, so that means all of this is hydroxide. So we need our moles, 9 millimoles, over our total volume. So what is in the beaker is now 200 milliliters. Okay, so let's figure out what that is. 9 over 200. 0.045 molar. All right, now this is a base. So I'm going to do POH first. 1.35. So that means pH is going to be 14 minus that, 12.65. So we have definitely overshot the endpoint of that titration.